Hello, Flat Earth researchers, debaters and debunkers. We are deceived from an early age into believing that horizons are caused by us looking across a curved spherical Earth. We are told that horizons just wouldn't be possible if we were living on a flat Earth because of mathematical models. But these just ignore or replace the observer's perspective with an imaginary curve on the surface. We are told because of geometry we are looking either at the top of a bulge or the beginning of a downward curve. But we can prove this is wrong with everyday observations across flat surfaces. This is a classic example of how our personal perspective or our frame of reference is converted into an external frame of reference or a perpendicular view of what we see to have us perceive that we are looking into a bulge or a curve. If we just go down to the second paragraph here. On a globe, the angle between the horizon and a level line of sight grows predictably with altitude. The following diagram demonstrates why this is the case. Conversely, on a flat plane, parallel lines of sight would appear to converge in the distance, and the horizon thus would always come to eye level. So right from the start, he's ignoring the observer's perspective and how looking across a flat surface will make that surface appear to rise to our eye level. And then using this perpendicular frame of reference or an external reference frame, those angles of perspective that make the sky and the surface appear to meet in the middle of our field of view are completely ignored. And we have this continuation of those parallel lines way off into the distance. Also ignoring the fact that that mountain, for example, would appear to become part of the horizon as we got further and further away from it. So again, those angles of declination that we would see from the observer's perspective are being ignored in this perpendicular external frame of reference illustration of the flat Earth. It's just simple ignorance. And we can prove with real-life observations and comparisons that something that appears to be on the horizon isn't at the crest of a bulge or about to go down a curve. This is a photograph of a boat that appears to be on the horizon because I'm crouching down close to the surface. It would be ridiculous to assume that any kind of curvature begins just a short distance in front of me, especially when we're told that you have to be really high to see curvature. It's just a contradiction. It assumes that I'm looking into this bulge of water like a wall just a short distance in front of me. But a second shot of the same scene taken standing up, adding an extra meter or so of height above the surface, shows the boat now below the horizon and the horizon beyond the boat. This wasn't taken with a tripod, so the camera isn't completely horizontal or parallel to the surface. If it was, though, that horizon would remain at the camera's eye level in the center of the field of view. This is simply what happens when we look across a flat surface. We just see more of it beyond the boat. And we can demonstrate this on a much smaller scale on a flat surface, proving that we can see various objects on the horizon even when they are at different distances from us. We can still have objects that are far away but only appear to be on the horizon because we are looking at them from a very low perspective. But when we rise up, we can see that those objects have space between them. There are distances across the surface between those objects that we cannot see when we have a very low perspective. And we can notice, for example, like the boat that was on the horizon, the figure in the foreground is on the horizon when we are looking from a low level. But when we rise up, just as we saw the boat go below the horizon, we see the figure in the foreground on the table is also below the horizon, that is the edge of the table. We can see in this footage how perspective changes the relative position of objects in the foreground to the horizon, which remains pretty much in the same place. The trees and the umbrellas, as we get closer, will now appear to rise above the horizon, while the horizon remains pretty much at eye level, although the camera isn't completely horizontal. But we also know at the same time that the horizon isn't a bulge of water in front of us. And we can also demonstrate that when we look across a flat, albeit rugged surface, as is found outdoors everywhere, whether it's a road or a lake or the ocean, when we are very low to the surface, the horizon or the surface appears to rise to eye level, and it will cut off objects that are on the surface but more distant than we can see across the surface itself. Here we have the camera on the ground, and we can see vehicles going off into the distance and appearing to sink below the horizon that is created. But as we rise up, we can see that this surface is flat, but we can see more of that surface. And we can also observe these angles of perspective that should be represented in any external reference frame referring to the observer's perspective. We see the parallel lines of the road and the pylons all appearing to converge in the distance, and everything going off into the vanishing point, the center of our field of view. So the surface is rising up, and the parallel lines of on each side of the road are converging or appear to converge, but they never actually meet. This is just because every time we use our eyes, we are using perspective. It is part of any observation that we make, and so must be accounted for. Here we can see that as we come down to the surface, we see less of the surface in the distance. The traffic gets cut off, and so do the bases of the traffic cones on the right. And we can also observe that when something does in fact go down a curve, which this red car is going to do at the end of the road, it's very noticeable. We see the car dip down the curve in a way that is obvious. And to round this off, let's look at some of those ridiculous arguments that are made about this apparent drop of the horizon when we look out of an aircraft window at high altitude. One completely false and frankly deceptive argument that has been made is that the wingtip of an aircraft is somehow a reference to our eye level. No, your eye level is where you are looking when you are looking straight ahead. A wing will bend upwards when an aircraft is in flight. It has nothing to do with where your eyes are. And of course, if we are flying at about 35 or 40,000 feet and we look out of the window, the horizon just isn't as clearly defined as when we are on or near the ground. We are often above clouds, which become the surface that rises up to our eye level. And we might have clouds at our eye level and clouds above us, which all converge at the line of convergence and become a very broad horizon in our field of view. And of course we know that the colors we see are all because of the light reflected from those objects, and the further we can see into the distance, the more everything just blends into one color. When it's light, it blends into white. So this blurry whiteness is passed off as a drop of the horizon, which still doesn't make sense and contradicts everything, because the further we can see, the more condensed everything becomes in the distance. So the higher we get, the more exaggerated curvature should become across our field of view. It just doesn't happen. The horizon is always at our eye level, and it is nothing to do with any alleged curvature of the Earth. Perspective is the imaginary curve on flat Earth. Thank you very much.